Hello everybody, welcome to our discussion on section 4.5 where we're going to discuss systems of inequalities. And there's three questions we basically want to answer with this discussion. The first is, how do we even graph an inequality in the xy plane? The second one, how do we define a system of inequalities? And thirdly, we'll go over how do we define a solution to a system of inequalities. Well, the first order of business is to define how we will graph an inequality in the first place. And the process really isn't that different from the process that we used when we were graphing lines in the first place. So let's go through this example right here to illustrate some of these points above. We are asked to sketch the graph of 3x plus 2y is less than or equal to 6. In fact, what we're going to do is that we're going to sketch the line 3x, let me get my pen working here, 3x plus 2y equals 6. But to graph it, because we're using the symbol less than or equal to, we're going to use a solid line. If we had less than or greater than, we would use a dashed line in its place. So the line 3x plus 2y equals 6. Well, we know how to do that. We could substitute it. We could substitute it and find our x and y intercepts very easily by letting x equal 0. Finding the y value that goes with it gives us a y-intercept at the point y equals 3. So we know that the point 0, 3 is on this graph. And substituting in 0 for y gives us 3x plus 0 equals 6. And solving for x gives us x equals 2 with a point 2, 0 as the x-intercept. So we would plot those things, 0, 3 here, 2, 0 here, and we would use a straight solid line right here to get those to connect here. Let's see if I can get them to connect the right way. Okay, and then the next question is, well, what do we do about that less than or equal to business? The next piece is that we shade a side of the line, one side or the other, by choosing a value and seeing which coordinate pair makes it true. So let's say we choose an easy point, like let's choose what we're going to call a test point. Right, so we're going to choose a test point right here. Let me get my pen working again. We're going to use what's called a test point, a test coordinate. And the easiest one, of course, is the origin, unless the origin is on the line itself. But we're going to use 0, 0 and see what happens. If we substitute in x equals 0 and y equals 0, does it make this inequality true? Well, the answer is yes. If we actually test this line, we find that the point 0, 0, 3 times 0 plus 2 times 0 would certainly be less than 6. So it certainly satisfies that inequality. So that's true. Now, if you were to check another point on the other side, let's say we were to pick the point 2, 2, 3 times 2 plus 2 times 2 would not be less than 6. So that's not true. So all of our shading would be done on this side of the line, and we would say that our solution region here, this part of the line, would certainly be fit our situation. And I'll shade that in here just a second. Okay, there's the shading, and you can see that everything that falls within this region certainly falls within the solution to this system of inequalities. So that's what we would do. We just take a pencil and shade this in. I see my shading's a lot better than yours on paper, but that's okay. Don't panic. It all works out in the end. Okay, so that's one example. Let me just show you another quick example of how this proceeds. Let's try a different one. Let's say this time we're given the graph of x minus 4y is greater than 4. Well, the procedure in order to graph this guy is pretty much the same that we did before. That is, we're going to start by graphing the line. We're going to sketch our graph of x minus 4y equals 4. Now how would that one look? Well, this is actually not a bad graph because if we put in 0 for x, solve for y, we're going to find that y equals -1, which is to say that we have a y-intercept at the point 0, -1. And if we let y equal 0, we're going to get x minus 4 times 0 equals 4, which is to say that x equals 4 is our x-intercept point for 0. So if we were to plot this one now, we're going to have to plot using a dashed line. So we have to use a dashed line to represent greater than or less than. But otherwise, everything proceeds exactly the way that it did before. So we're going to graph our line. Now, let me get my points here first. Let's see. 0, -1 was one of our points right here. 4, 0 was our other point. And if we were to plot our line through those two, we're going to plot it using a dashed line. So let's see. See what I can do about aiming this line about correctly right there. Okay, that's good. And then let me set up some properties for this line right here. Let's make it a nice dashed line here. Here we go. There we go. So that's what our line should look like. Okay. So now what else do we do? Well, we're going to have to find a test point to check. So 0, 0 is a point that is not on the line. So let's go ahead and test it. We're going to test 0, 0 again and see what happens. Does that make the inequality true? Well, in this case, 0 minus 4 times 0, if that is a solution, would be greater than 4. But 0 is not greater than 4, so it is not a solution. So our solution set will be everything on the opposite side of that line. So that's the part that we're going to shade in, and I'll do that right now. Okay, so there's my shading. Of course, that means that everything that is below the line would certainly be in the solution set. And if we picked any point within this region, we'd have solved our solution. So, more in the next video.